When you're running in a complex microservice architecture, one of the big challenges is understanding how to troubleshoot and isolate what's going on with one of my workloads. This is right off of CNCF's own blog, and you can see they've got a really trivial example here with a couple of pods and a couple of databases, and just this has got A1, 2, 3, B, and a lot of different dependencies just to build a trace that shows you how everything works across the whole system. But your code may not be organized that way. Your code might be organized by the resource here, and I actually need the code that just goes with a particular pod so I can pull it out, run it, and debug it on my own machine. So one of the other tools in the toolkit you can use here is traffic capture and analysis. So we specialize in this at Speedscale, and what we've heard, sometimes our customers say, I need to get the data from the production environment. That is where things are happening, but I've got to keep it in my own cloud. We offer a deployment option called BYOC, bring your own cloud. You can take the rich Speedscale traffic that shows you which APIs, the data, the payloads, and what is needed to reproduce issue on your local machine, but you can store it in your own cloud. And the way we do this is through OTel, Open Telemetry compatible exporters. So we offer a bunch of different examples of these. I'm going to show you how it works with Elasticsearch. The data coming out of Speedscale is in OTel logging format. So Elasticsearch is an obvious choice here. It's one of the most popular log visualization tools. We've also got demos for others like Grafana, or even just writing data straight to a storage bucket. The way that it works, you use the traffic capture system, our eBPF agent, which can pull the data right from the node, does not impact your app at all. Send it to the Speedscale forwarder. You can run your security rules, your data loss prevention, drop and filter out traffic that doesn't apply. Export the data you want to keep into your collector. You can fan it out to multiple collectors and different destinations if you need. I'm going to show you Elasticsearch and visualizing the data in Kibana. And then the second part I'm going to show you is after you visualize the data, you want to pull it down and run it locally. So we offer a little script here that will hit the Elasticsearch API, build a directory, and then you can use proxymock and actually see all of the details and reproduce against your own code base. So at a glance here, this is kind of a view into what's happening right now in my cluster in Elasticsearch. I've got traffic coming from a bunch of different endpoints here. They're all flowing in. This is just an out-of-the-box dashboard so that you can see, okay, traffic's flowing. I know the specific endpoints. I'm seeing the data I'm expecting to see. You can always drill down to the more traditional Kibana interface where you can build a table of your own data here. So I'm actually focused on one of my endpoints, outer space server, because it's running into a couple of problems. You can see here every once in a while I'm getting these HTTP 500 errors. So I want to grab a snippet of traffic here, maybe this last 15 minutes, and pull it down on my local machine. So what I do is flip over to my IDE, and I've got the code here for this app locally available. This is also on GitHub. You can see this repo. And what you want to do is run this script, and you've got a couple of different parameters that you can pass in. So I'll make this a little bit bigger. So I want to pass in where's the Elasticsearch endpoint. In my case, it's actually running in the VPC, so it's firewalled off, but I can remote into it, and I've got a port forward so I can see it, which service I want to work on, how much traffic I want to grab, 15 minutes. You can put whatever you want in here, 30 minutes of traffic, and where do I want to write the output directory. So in my case, I want to write it here into my proxymock directory. So I'm going to copy that and paste it. I got something funny in there. Copy that and paste it. And you can see here, that was pretty fast. It went and grabbed 207 pieces of traffic and it wrote it here into my proxymock directory, and I can see the individual calls. Now, they're coming through as JSON blobs in this case, and maybe a little difficult to read. You can always ask your AI agent, summarize the data in the proxymock, summarize the data in the proxymock directory, and these agents know how to read this data because it's structured type of data. We also offer the proxymock command line tool that you can also use, but this can give you at a glance kind of visibility into what's going on, and you can see it's able to see the HTTP 500 errors that I pointed out, and also try to understand what do I have locally, what does it tell me that's going on, which endpoints are getting hit, and what are some of the interesting patterns. Okay, so this is already super helpful because I can reason about what's happening in my production environment and give it to my coding agent. Another option here is to use the proxymock web interface, and this will show me kind of a visual view of the data. It's all ordered by time here, so I can go through and see any of these specific calls, like this HTTP error message, and actually see what was returned in the response. So it's actually pretty telling here. There is a problem. There's some kind of control character. You saw I had problems with my copy paste. I probably made some error when I pasted something, and there is invalid characters, and that's why sometimes we're having problems when this is getting called. This is the type of thing that you don't always see when you're just getting kind of some high-level logs and traces and things like that. So now I've got the data. I'm actually already running this on my machine. I can take this traffic if I want and say run it, not to outer space server, but I'll run it against localhost 8080, and this can actually take what was observed from the production system and replay it locally on my own machine, and we actually got the same responses. So I've actually reproduced the problem, because even though it says, hey, the match rate is 100%, it was having errors. So we've been able to reproduce the error here, and you can drill in, and this is the calls that were just made a few moments ago, and we are able to reproduce the exact same call that's happening, that sometimes it's working and sometimes it's not. I've now got what I need for my reproducibility, and I can hand this off to an AI coding agent and say, this is the problem, here's how you reproduce it, fix the bug, and then show me that it's fixed when you're done. This is the big thing you're always looking for. It's nice, I love observability and getting some high-level information and that things are called, but I need to drill down to the details. But hey, I've got to keep the data in my own environment. So with Speedscale and Bring Your Own Cloud, you now can control where the data goes, keep it inside your four walls, your own production sensitive data, and it never leaves. You can use local LLMs and use the approved agents from your own company, so you know that the sensitive data is there. You've got what is needed to reproduce an issue, but it's all been done in a safe way. So if you've got questions about this, check out more information here on speedscale.com/BYOC, and I will include the links to all the GitHub repos. And if you want to reach out to me, you can also join our Slack community, and feel free to jump in and ask questions. Thank you very much.